So up until now, we've only passed a single parameter. Let's pass more than one. And we're going to use this type called relook. And notice that we are passing two parameters to it. N, which we're not specifying at all, it's just N, and T, which must be the subset of real. We're going to have a single field name, duration, which is of type T, the same parameter there. So whatever we created it with, it would be the same. End. Now, what I'm going after here is a simple example of operating on someone. We might need to do a second or follow-up operation. We might even need to go back twice or three times. And just as an aside, we usually see that with severe sepsis, that we get source control, but we might have to go back a second and a third time or fourth time even. So that's just a bit of motivation for this type. Irrespective of what we're trying to achieve here, let's just call it relook, and we're passing two parameters. So a bit more complexity to these parameters. Let's execute that. And indeed, we have a new type, and it's going to be called relook. Now, if I instantiated this by saying patient underscore 1 relook 3,60, we are going to get an error. You might say, well, why would that be? I've parameterized it. That is an integer as far as the two t values are concerned. So whatever this field value is, or the type of the field value that I do pass, it should just work, but it doesn't. It throws this inner constructor error. There is a problem with the convert function. And once again, it's a bit difficult to figure out exactly why this should fail. We see that we did pass two 64-bit integers, and we would assume that we would just get something back. The problem is almost what we had above, in as much as we do need to specify the type. So we're going to instantiate it by saying patient underscore 1 relook, and then 4, that's the value for this n up here, and then for the 60, we have to tell it that this is going to be a 16-bit integer. That goes inside these curly braces. So both the reference for the reference to the n and the type of the t parameter value has to go inside. They both have to go inside of these curly braces, and then we pass the value 60. And if we now look at that, we see an instantiation of our relook type, and it says relook 4, 64-bit integer referring to the 60. If I just look at the field value, patient underscore 1 dot duration, we're going to get this value 60 back. Now let's tell Julia what to do if we want to add two instances of this relook type of ours. Now we've imported base.plus before, so we can just use it now, plus. I have to put in curly braces now with this more complex parameters of mine. I've got to put them both in n, t. It almost says for all n and t. Take two instances, which I'm again going to refer to as u and v. You can use whatever you want. Relook n, t, v, which is of type relook n, t. Take that, this is an assignment. So take relook, both my parameters again, and take the u dot duration and add the v dot duration to that. So that's fairly simple to just overload the methods for the plus function. And now we see we've gone up to 173 methods. Remember, base we had 171. We added one for our vector underscore 2D type, and now we've added another one for our vector for our relook type. Now let's create patient number 2, and we're going to call it patient underscore 2. It will be the relook type again, the 4 with reference to the n, 16-bit integers for the 70. And I do that now. I can add patient 1 and patient 2, and I would have relook 4, and my duration values were added. 60 plus 70 would be 130, and they are 16-bit integers. Now, just for argument's sake, let's create a patient underscore 3, relook, but instead of 4, remember both patient underscore 1, patient underscore 2 had an n value of 4, but let's create one with a value of 3. 16-bit integer for my value 70. I've got that now. If I were to now say use patient underscore 1 plus patient underscore 2, I'm going to get a method error. It said I cannot add this relook type for 16-bit integer and relook 3 16-bit integer. So those values were 60 and 70, whatever they were. There's a difference between 4 and 3. What I'm trying to get here is a type that I do not want to be able to add two instances of that type if this n parameter is not the same for both instances of my type. I might want to compare patients who's had 4 relook procedures or repeat procedures, and I want to only compare or add the duration of the operative times of patients who've had 3 relook procedures or performing 3 other procedures on them. So just again a bit of motivation for this type. The thing though is I have not defined, or I have not told Julia what to do to add these two instances if these values are different. So let's create this patient now. So the 3 didn't work, but let's create a patient that does not hold a value, that holds a value of 4, but this time it's not an integer, it's actually a floating point value, 4.0, and still a 16-bit integer for my second type if I were to have that patient. And if I now want to add it, I'm going to get exactly the same error. It says here that the first one was 4, the second one was 4.0. And the values might match, but the types don't match. And once again, that means there's no method for the addition of 2 instances of my relook type. Now we can fix this type mismatch. First of all, let's just look at fixing 2 different types of the duration field. So n I'm still leaving on its own. So this time I'm saying for all n and 2 of these duration types, T1 and T2, I'm going to refer to them again, 2 instances at least of my type U and V. The first one is going to be relook n, T1, the first one n, T2. And I assign to that, take relook n and then promote type. Remember, we looked at promotion. Take T1 and T2 and see what the smallest Julia type is that can encompass both of these so that I can do this addition of these 2 duration fields. So that's quite easy to see. So if I can now do something different above, we just had 16-bit integers. Let's just run this and then create this patient underscore 5, relook 4, because we haven't done anything to the ends. So it's got to stay the same if I want to add them. And then a 64-bit float of that 60, which means I get back this relook 4, a 64-bit float of the 60, but I can now do a patient 1 plus patient 2, because we've promoted the 16-bit integer to a 64-bit float, because our first patient had a 16-bit integer value for its 60 value. The second patient, patient underscore 5, had a 60.0 floating point value, but we have promoted those types T1 and T2 to 64-bit integers, meaning we can still do the addition of the 2 duration field values, and we get indeed, it is now a 64-bit float of 120 minutes. Now, you might be writing code for someone else or write code for yourself. You cannot remember what you wanted to do if something goes wrong, if those n values were not the same, 4 as an integer and 4 as an integer. So here I'm just going to define what error to throw if, by using this assignment, if those values are not the same. So I'm going to say for all n1, n2, and t, 2 instances of my type U and V. The first one will have n1, the second one will have n2. If I try to add them, I want this throw argument error, cannot add duration when the number of relooks do not match. So if I now were to say patient underscore 1 and patient underscore 3, it's going to throw an error reminding either myself or someone who's using my code to say cannot add durations when the number of relooks do not match. Quite simple. Now, what about calculating the natural logarithm of the duration of a relook? So I can say, what is the natural log, it's a Julia function, of patient underscore 1 dot duration, that field value. And it will work out that log for me. But what if I don't want to go through all of this? I just want to say, well, log of an instance of that type. So I'm going to import base.log. And I'm just going to say this. If I take the log of U, which is of type, so any instance, which is of type relook, please let that be the log of the duration field value of that instance of the type. So if I've done that, I can now just say log of patient underscore 1. I don't have to refer to log underscore patient 1 dot duration. I don't have to refer to that field name to get its value out of the instance of that type, because I've done this assignment here as a sort of outer constructor. Now let's just specify something with a convert function, so that it would convert all the values, all the instances, just to the duration field. So I'm going to import base.convert, and I'm going to use this assignment to say, take the convert function. Now, this is a bit tricky, so look at it. As arguments, I just say double colon signs of a type abstract float in curly braces of an instance of this relook type would be equal to the floating point representation of the duration field value. That is going to be a new method added to my convert function, which now says that any function that I now use as an argument to a Julia function, here we're going to use the log base 10, I can convert that value just to a value by using this form of the convert function. Convert to an abstract float, patient 1. It will use this assignment now to extract that value and use it inside of a function for which we have not specified a method for this particular user type of ours. If I say log base 10 of an instance of my type now, it will extract or convert at least from that method, from that instance of my type, just that duration value as a 64-bit float, pass that to this function, and we will get our result. So that's quite a bit about how to specify things as far as our user types are concerned by looking at more complex parameters. Last up, we're just going to look at what to do to print things to the screen that might help our users or ourselves down the line, just to remind ourselves or our users what a new type is all about.